Good afternoon students, it is DTSP Unit 5. We have the some multiple applications of DSP. Here always supported for that is adaptive filter based applications. Here the adaptive noise cancellation, frequency tracking, adaptive channel equalization, then adaptive echo cancellation, adaptive line enhancing technique also supported. Here the examples of adaptive filtering is IIR and FIR filter can use in adaptive filtering, but FIR filters are mostly used, that is FIR filters have the following reasons, that is simple, it has only the adjustable zeros. Okay. So now we see about adaptive noise cancellation diagram. Here the desired signal with noise signal, that is x of n plus w1 of n, it is moved to the observed signal y of n, that is w2 of n. Here the w2 of n is the interference signal. Here the unknown linear system h of z is available, that is we called as the z2 of n. Then observed signal z of n. Here only adaptive FIR filter is available. Here one of the application part. Then we can add the adaptive algorithm. So finally, so all the adaptive FIR, then adaptive algorithm. So the noise signal, or it is otherwise called as the desired signal, is applied to the adaptive FIR filter as well as the adaptive algorithm, means we get the result of output. Then error signal E of n is also available. Here the compared to the original signal and get output of the received signal, we have to compare it, means finally get the error signal. Error signal is defined as the E of n. Here see the some calculation is available, let x of n is the desired signal and this signal is corrupted by an additive noise signal, it is called as the W1 of n, and also additive interference signal is W2 of n. Okay. But the output of the unknown linear system is Z2 of n, and the signal is added with the interference noise W3 of n, and observed signal Z of n is defined as, this is the explanation for the above diagram, that is Z of n equal to Z2 of n plus W3 of n. So the estimate of the interference signal W2 of n is obtained from one FIR filter. Okay. The estimate of the desired signal x of n is the error signal is given by E of n equal to y of n minus W2 cap of n. Okay. Then y of n equal to, we have to expand the W2 of n, summation k equal to 0 to m minus n, h of k is z of n minus k, where W2 cap of n is the estimate of W2 of n. The error signal is used for adjusting the FIR filter coefficients. In the same way, adaptive channel equalization is the very important topic for the whenever go for the amplitude variation or in the other output side variation, we go for the equalization is good. Then adaptive channel equalization, okay, the data sequence, transmitter section HT of n, then channel section HC of n, finally receiver section is also available. So always the equalization is supported for the receiver section. Here for the adaptive equalizer, the decision device is also followed. After getting the decision device, the reference signal is followed. So from that reference signal and the decision device output, we get the error signal. So that error will be changed, the error will be that is the error will be bring to the good manner, means we go for the adaptive algorithm of operation. Here the adaptive equalization process is done in two steps, there is a training mode and the tracking mode. In training mode, a known test signal is transmitted using a synchronized version of the test signal and the receiver side, and comparing this signal with the receiving signal. After comparing these two signals, the resultant error signal give the information about the channel. Then the training process, the adaptive quantizer can be continuously adjusted in the decision directed mode. Then only the error signal got from the final receiver estimate, it will be the good. Okay. The output of the adaptive equalizer is sent to the decision device, now the receiver to get the estimate. The error signal estimate is used to adjust the coefficient of the adaptive equalization. Then here the bandwidth of the channel has to be used efficiently. So the basic requirement is to design the reliable system with the data to be transmitted at a higher rate. There are two factors affect the data in the channel. One is intersymbol interference, another one is the thermal noise. That could be calculated by using the algorithm. So adaptive equalizer is mainly used for compensating the channel distortion, show that the detected signal will be reliable. Output of the receiver filter is S of t equal to summation k equal to 1 ak p of t minus kts. T Ts is the duration of the signaling interval, P of t is the impulse response of the cascade connection, Ak is the original data, sampled version of S of t. So, finally, we conclude S of t equal to Ak of P of 0 plus summation A n P of k minus 1. So, P of 0 is a normalized function, is always 1, Ak is the original output, right. Thank you.